vector A is there, then this can be resolved in AXI plus AYJ. Basically, this I and J, they are unit vectors in X and Y direction respectively. Actually, I is denoted as, since it is a unit vector, it is denoted as like this, and J is denoted as like this. So whenever you denote any unit vector, this kind of sign is placed on this, and for denoting a vector, it is, so A is a vector, it can be resolved in AX, AY, AX and AY, they are both components in X direction, and Y direction, these are basically magnitude of the components. And suppose you have B vector, then this can also be resolved like this, and what about resultant vector? This will be like this, and this can be written as AX I plus AYJ plus BXI plus BYJ, or we can write it as AX plus BX I plus BAY plus BY BX BY, it will be J. And this R vector, we can write it as RX I plus RY J. That means this is RX is here is nothing but AX plus BX, and RY is nothing but AY plus BY. Correct? And this is, we are talking about a plane. So we will restrict our discussion with two dimensions only, X and Y. Now one more thing here is, in NCERT one question is there, this is a B vector and this is a vector. We can make a parallelogram like this. And what will be the resultant? Resultant of A and B will be this. This will be your R. We have to find out this alpha. Means the angle resultant is making with one of the vector, that is A. So suppose these two vectors are at an angle theta with each other, it is given then what you can do is, what about this? This will be nothing but your theta, because this is parallel to this. So here in this case, this is theta, then naturally this will be your 180 minus theta correct. And if we drop a perpendicular on this, this is your B. Naturally this will be nothing but B sin theta. And what about this? This will be B cos theta. So tan alpha will be nothing but B sin theta upon A plus B cos. So this is how you can find out the alpha. Correct?